Good morning students. In the previous video lecture, we have discussed about the basics of 8051 microcontroller and also the pin diagram and pin description of 8051 microcontroller. In this video, we will see the 8051 microcontroller architecture and the different components in the architecture. We have already seen the pin diagram of 8051 microcontroller for its standard 40-pin dual inline package configuration. In this video, in the process of dealing with the 8051 microcontroller architecture, we will see the hardware aspects of 8051 microcontroller like I/O ports, RAM, ROM, timers and serial ports, etc. Before going into the details of 8051 microcontroller architecture, we will first see the basic components of microcontroller, which makes a microcontroller a true computer on chip. The difference between a microprocessor and a microcontroller is availability of the on-chip peripheral like memory, I/O port, timer counter, communication interface, etc. The image shows the basic component of a microcontroller. As all the components are integrated on a single chip, a microcontroller can act as a microcomputer or a computer on chip. Let us see about each and every blocks in detail. Central processing unit. It is the heart of the microcontroller that mainly comprises of an arithmetic logic unit, a control unit and other important components. The CPU is the primary device in communicating with peripheral devices like memory, input and output. ALU or arithmetic logic unit, as the name suggests, performs the arithmetic and logical operations. CU, control unit, is responsible for timing of communicating process between the CPU and its peripherals. Next, about program memory. The instruction of the CPU are stored in the program memory. It is usually implemented as read-only, where the program written to it will be retained even when the power is down or the system is reset. Modern program memory modules are generally made up of electrically erasable programmable read-only memory, that is EEPROM, which is a type of non-volatile memory. In this type of memory, the data can be erased and reprogrammed using special programming signals. When the microcontroller is powered on or manually reset, the processor executes a set of instructions from a predefined memory location in the program memory. Let us discuss about the data memory now. The data memory in a microcontroller is responsible for storing values of variables, temporary data, intermediate results and other data for proper operation of the program. Data memory is often called as random access memory, RAM, which is a type of volatile memory. It is generally organized as registers and includes both special function registers and some memory locations. Input and output port provides the microcontroller a physical connection to the outside world. Input port provides a gateway for passing on the data from the outside world with the help of sensors. The data from the input port is manipulated and will determine the data on the output port. Output ports allow microcontroller to control external devices. Generally, all ports in microcontroller have dual functionalities. That is, they can act as both input-output port, not as the same type. Clock generator. A clock signal allows the operation inside the microcontroller and other parts to be synchronized. A clock generator is an integral part of the microcontroller's architecture and user has to provide an additional timing circuit in the form of a crystal. Intel developed the 8051 microcontroller in 1980s. The microcontroller IC consists of standard on-chip peripheral, that is timer, counter, UART, 4 kilobytes of on-chip programmable memory and 128 bytes of data memory. The 8051 has separate address space for program memory and data memory with the help of modified hardware architecture. The program memory can be increased to 64 kilobytes. Approximately 4 kilobytes of program instructions can be stored in the internal memory of 8051. The 8051 can address up to 64 kilobytes of external data memory. The 8051 memory architecture includes 128 bytes of data memory that are accessible directly by its instruction. A 32-byte segment of this 128-byte memory block is bit addressable by a subset of 8051 instructions, namely the bit instructions. For this reason, the 8051 microcontroller is known as a Boolean processor and is used to deal with binary input and output conditions very effectively. In addition, the device has a low power static design which offers a wide range of operating frequency down to 0. Two software selectable modes of power redundant, ideal mode and power down mode are available. The ideal mode freezes the CPU while allowing the RAM, timer, serial port and interrupt system to continue functioning, whereas in the power down mode it saves the RAM content but freezes the oscillator. The detailed architecture of 8051 microcontroller has been depicted here, which consists of ALU, control and timing unit, RAM, EPROM, ROM, registers, latches and drivers for port P0, P1, P2 and P3. The operation of each block has been explained now. All operations in a microcontroller are synchronized by the help of an oscillator clock. The oscillator clock generates the clock pulse by which all internal operations are synchronized. A resonant network connected through pin XTAL1 and XTAL2, which we have discussed in the previous video while we are discussing about pin diagram, forms up an oscillator. For this purpose, a quartz crystal and a capacitor are employed. The crystal runs at specified maximum and minimum frequency, typically at 1 MHz and 16 MHz. Let us now discuss about the ALU. ALU, it is a 8-bit unit. It performs arithmetic and logical operations such as addition, subtraction, multiplication, division, increment and decrement. It performs logical operations like AND, OR, XOR. It manipulates 8-bit and 16-bit data. It calculates the address of jump location in relative branch instructions. It performs compare, rotate, complement operations. It consists of Boolean processor which performs bit, set, test, clear and complement. 8051 microcontroller contains 34 general purpose registers or working registers. 2 of them are called math registers. A and B are called as math registers and 32 are bank of registers. So totally 34 registers are being there, in which 2 registers A and B registers are being called as math registers and rest 32 are being called as bank of registers. A register or accumulator, it is a 8-bit register. It addresses E0H and it is bit and byte accessible. I will repeat it. Accumulator is a 8-bit register. its address is E0H, that is we can directly address the accumulator. Instead of writing as A in the instruction, we can directly give the address as E0H. If we give E0H, then the microcontroller will know that E0H is nothing but of the address of accumulator, and it will load or it will take the data from the specified address, that is E0, which is being meant only for accumulator. So if a program consists of an address E0H, that is 00E0H, then it indicates accumulator. This accumulator is bit as well as byte accessible. So what only I have named this processor as a Boolean processor. This processor can handle both bit as well as byte operations. So it is a bit and byte accessible one. The accumulator is bit and byte accessible one. Result of arithmetic and logical operations performed by ALU is accumulated by the register A register. Therefore, it is called as accumulator register. It is used to store 8-bit data and to hold one of the operand of arithmetic logic unit during arithmetic and logical operations. Most of the instructions are carried out on accumulator data. It is most versatile of 2 CPU registers. Next, we will see about B register. It is not being present in our 8085, but the 8051 has this B register. Let us have a close look on the function of B register now. It is a special 8-bit math register. It is a bit and byte accessible, as similar to that of the A register. Since 8051 is a bit as well as byte processing processor, we have also named it as Boolean processor. So all the registers are bit as well as byte accessible. It is used in conjunction with A register as a input operand for ALU. It is used as a general purpose register to store 8-bit data. Let us now discuss about the math flag. Carry flag. During addition and subtraction, any carry or borrow is generated, then carry flag is set. Otherwise, carry flag is reset. It is used in arithmetic, logical, jump, rotate and Boolean operations. Next, about auxiliary carry flag. If during addition and subtraction any carry or borrow is generated from lower 4-bit to higher 4-bit, then auxiliary carry is set, elsewhere it is being reset. It is used in BCD arithmetic operations. Next, about overflow flag. If in signed arithmetic operations results exceed more than 7 bits, then overflow flag is set, else reset. It is used in signed arithmetic operations only. Next, about parity flag. If in the result even number of ones are present, then it is called even parity and the parity flag is being set. In result, if odd number of ones are present, then it is called odd parity and the parity flag is reset. Let us now discuss about the control flags. The control flags are FO, RS1 and RS0. Let us first discuss about FO. It is a user defined flag. The user defines the function of this flag. The user can set, reset, clear this flag through software. Now let us talk about this RS1 and RS0. These flags are used to select the bank of registers by resetting those flags which are being shown in the table. If RS1 and RS0 are of 0, then bank 0, register bank 0 is being selected. If RS1 and RS0 are of 0, 1, then register bank 1 is being selected. If register bank RS1 is equal to 1 and RS0 is equal to 0, then register bank 2 is being selected. If both RS1 and RS0 are is equal to 1, then register bank 3 is being selected. Now let us have a look on program counter, data pointer and stack pointer. Let us begin with the program counter. The program counter is a 2-byte address which tells the 8051 where the next instruction to execute is found in memory. It is used to hold the 16-bit address of internal RAM, external RAM or external ROM location. When the 8051 is initialized, program counter always starts at 000H and is incremented each time an instruction is executed. It is important to note that the program counter is not always incremented by 1 and never decremented. Data pointer. It is a 16-bit register used to hold address of external or internal RAM where data is stored or result is to be stored. It is used to store 16-bit data. It is divided into two 8-bit registers, data pointer higher and data pointer lower. The data pointer higher and data pointer lower are bit addressable. The data pointer higher addresses 83H and data pointer lower addresses 82H. Each registers can be used as general purpose registers to store 8-bit data and can also be used as memory locations. Data pointer does not have single internal address. It functions as base register in base relative addressing mode and in direct jump. Stack pointer. It is a 8-bit register. It is byte addressable. Its address is 81H. It is used to hold the internal RAM memory location address which are used as stack memory. When the data is to be placed on stack by push instruction, the content of stack pointer is incremented by 1, and when the data is retrieved from stack, content of stack pointer is decremented by 1. Let us discuss about the special function registers of 8051. The 8051 microcontroller has 11 special function registers divided into 4 groups. Timer counter register. 8051 microcontroller has two 16-bit timer counter registers called timer register T0 and timer counter register T1. Each register is a 16-bit register divided into lower and higher byte registers. These registers are used to hold initial number of count. All of the 4 registers are of byte addressable. Timer counter register. 8051 has two 8-bit timer counter registers, that is Tmod and Tcon registers. Tmod register is a 8-bit register. Its address is 89. It is used to select the mode and control operation of time by writing the control word. Next register is Tcon register. It is an 8-bit register. Its address is 88H. Its MSB 4 bits are used to control operation of timer counter and LSB 4 bits are used for external interrupt control. Serial data register. SBUF. It is a 8-bit register. It is a byte addressable register and its address is 99H. It is used to hold the data which is to be transferred serially. Serial Control Register SCON. It is a 8-bit register. It is bit and byte addressable. Its address is 98H. The 8-bit loaded into this register controls the operation of serial communication. These two SBUF and SCON are nothing but of serial data registers of 8051. Next, interrupt registers. 8051 microcontroller has two 8-bit interrupt registers, IE and IP. The interrupt enabled register IE, it is a 8-bit register. It is byte and bit addressable. Its address is A8H and it is used to enable and disable the functions of interrupts. Next, interrupt priority register. It is a 8-bit register. It is also a bit and byte addressable one. Its address is B8H. It is used to select lower or higher level priority of each individual interrupts. The next special function register is PCON register. This register is a 8-bit register. It is a byte addressable. It can't be bit addressable. It is a byte addressable register. Its address is 87H. Its bits are used to control mode of power saving circuits, either ideal or power down mode, and also one bit is used to modify baud rate of the serial communication. Let us discuss about the internal RAM and ROM of 8051. Internal RAM has 128 bytes. 8051 hardware for further internal RAM is organized into three distinct areas: 32-byte working registers from address 00H to 1FH, 16-byte addressable occupies RAM byte address 20H to 2FH. Altogether, 128 addressable bits are being there. Internal ROM is nothing. The data memory and program code memory both are in different physical memory, but both have the same address. An internal ROM occupies address from 000H to 0FFH. The program counter address program code from 000H to 0FFH. Program address higher than 0FFH that exceeds the internal ROM capacity will cause 8051 architecture to fetch code byte from external program memory. Let us discuss now about the program address register. The program address register, this is an on-chip EPROM and a basic circuit mechanism to internally address it. EPROM is available in 8051, 8052, 8751 and 8752 microcontroller, and it is not available in 8031 and 8032 microcontroller. This instruction register is being used to decode the instruction. This register is used to decode the opcode of any instruction to be executed. After decoding, this register sends the decoded information to the timing and control unit to generate necessary signals for the execution of specified instruction.